some of the plots like heat map we have seen. We can also try to see one of the plot called count plot. Let me just use Titanic. Okay, and I see that, okay, this is the survived and the count for survived passengers, and the zero is a male and orange is a female. Okay, so these are the people who have survived based on the the count plot, which is the representation, or we can probably use one more option called hue. Okay, and that is, let's say, equal to 6. Okay, so based on, okay, I think yes is capital, right? Yeah, so based on the 6, we understand that, okay, this how many people survived, and how many have not survived out of the whole passengers. So that there are males who survive, who have not survived, this is a blue, and orange is females who have survived. Okay, this one is for survived. So how many male and female survived? So female is orange and male is blue. And how many have not survived? So blue is not survived, close to 450 or maybe more than 450, and orange we have not survived. So that is the the plot which we can see. Okay, so this gives a quite good amount of information with the data. Now let me also discuss about something out of this data. Now suppose I want to use this data to have some predictions for using some machine learning techniques, and we want to see that, okay, based on the information provided, what kind of relationship we can probably bring out. Okay, so we can say that, okay, survived is a target variable, so all other things are the features. So based on those features, we see that, okay, a person has survived, and or the person has not survived. So rest of the other fields are, other columns are the features, or they are called independent variables, and survived is the target variable, or we can call it as dependent variable. Okay, now if I want to use this survived as one output out of this analysis, so all others are the features for this analysis, right? And now let me understand little bit more about this data, right? Passenger ID is the ID for each passenger, probably it's a unique one. Passenger class, okay, there is a class. So now suppose I take any one passenger, so what are the, if that passenger is survived or not survived, what is the importance of passenger ID in the passenger survival? So right, so I don't think passenger ID plays any important role, but class might play, because we have to now understand how many people survived out of class, or class wise survival of the people, right? So that kind of analysis is all about uh, exploratory data analysis, which we want to explore based on the maybe the passenger class, or based on the the sex or age. So all this information is very important, and understand the relationship between the features and the target variable. So here what I see is passenger ID has no relevance. Same way, name is not important feature in the survival or not survival of this particular passenger in a Titanic, right? But yes, male, there might be some relationship between the survivor and the sex feature or the age feature. So maybe the sibling information, if somebody has siblings, or if they have survived or they have not survived, we might derive some relationship between all these features, it seems, right? Except again, ticket. So maybe based on ticket number, I don't think there is any relationship between the ticket number. Okay, or if there is any, we have to work out with that, right? But for now, we can ignore these are these few columns like passenger ID, name, and ticket. Okay, so how to ignore them, how to drop or how to remove from the this particular data set is using a drop function. And in drop, suppose if I use a list of information, let's say passenger ID. Okay, so let me copy just to avoid the spelling mistakes. And I'll go for name. Name is not important. And let's say ticket, or maybe, yeah, for now we will go with ticket. And now I will also want to you know help you understand that cabin, there is a lot of information missing, and it's really difficult to deal with such a data where majority of the data is missing, right? So I think cabin can be removed as well. Okay, so now look at this. What happened? I was trying to remove all these columns, but it gave some error saying that there is no such axis available. So we have to use, axis equal to 1, because I want to make it column wise removal, right? The rows I want to remove, but based on columns. So uh, look at this. I got data which is shorter now, but this data has not reflected, this change has not reflected into Titanic. So I need to use in place option argument here, so that the change has happened then and there itself in the data frame. Okay, and this is my the next data frame, how it looks like. Okay, let me go back and again do something with this particular heat map and understand. Now look at this, there is no cabin, but now somehow we have to deal with age. Okay, so there are many passengers age is missing in the data set. So now we have to do somehow that how we can predict, or how whether we should add or fill up that data, or we should ignore those rows. Okay, so suppose I have 10 passengers and all the information I have, but only age. So in that case, instead of ignoring those 10 passengers, if I have somehow some mechanism to fill up the age information, maybe I'll take a average age of the passengers in the Titanic, or maybe I'll take a average age of passenger for for the classes this passenger is traveling. So maybe I can have my own algorithm to decide how I want to have this age information, so that the whole other features I can use to derive the relationship between the target variable and the and the features, right? So there are many ways. Now it's up to you what you want to do with this. You want to predict or get the age based on the passenger class, based on the average of the passenger class. So I have an idea to use this a new age from the data which we are passing. And probably let me first write down Titanic dot age, or age equal to Titanic age comma, let's say P class. Okay, the reason I am using P class is I want to predict the age of the passenger. If the passenger is on passenger class 3, so I want to get the average age of all the passengers who are traveling in class 3, so that I can use that particular number to replace. Okay, so that way I can apply some of this functionality which I'm going to write. I haven't wrote till now, and I will apply this on the axis. So something I need to do like this. Okay, now something happened, but this would not be the good one. So for now, maybe where is the age? Yeah, so every age become none, because we have applied this the function which doesn't return anything. So let me go back and run our original data, get our original data once again, and then we will then I'll continue. Okay, yeah, so let me do this here. drop it. Yeah, this is how it looks like. And now I want to fill up this function because it is now it's important for us to know. Now x value is this age and p class, correct? Because this is where I'm applying this functionality. So now if I want to get age from this one, so it will be x of 0, correct? And if I want p class from this, it is x of 1. Okay, if I get this, now I want to check if is null information for age. Okay, if age is missing, right, then I want to set something, right? What I will set, what I have to set, we will see that. Otherwise I simply return whatever age we have. Okay, if not present, what to return is return the Titanic. I want to group by, okay, group by, sorry, group by using passenger class, okay, p class, and I want to take the mean of all this uh, information and get the age, and I'll return the p class. Sorry, p class is already we have received here in the second argument of this. So this way, if I return this whole thing, okay, I will get you know I'll get what we are trying to apply. Okay, so maybe let me check this once. Not sure if it works. Okay, so let me see. Yeah, it works, it seems. So we had some missing information. Let me just show you again. Yeah, so here suppose I now if I print this head, I can see that the age is okay for the first Titanic. Okay, okay, for first 5 rows I don't see anything missing here, but yes, see, if I print 10 rows, I see that on the fifth index I see there is a NaN that is missing information for this particular passenger, correct? Now after this, if I run and display, I see that the fifth index passenger is now filled up with 24.14, right? So that is what we are trying to predict. So now I just want to get the numbers. I don't want this many decimal point. I can do one thing. I can round this up so that we can see. Sorry, ROUND spelling. Okay, and I can see that okay, the ages is this information is now rounded, and I can see the only 25. Okay, cool. So this is how one of the way we can replace some of the missing information. So there are multiple ways how to replace the missing information in the multivariate analysis. Okay, so this is what it looks like. Missing information, we can ignore those rows, or we can fill up this information using some values. Maybe you can use the zero values, or you can use the sum of or the average or mean or median. So or a mode value, it is up to you, based on the based on your business case, or based on your data. You should understand as part of your data science project, we should know about our data first, our features or our domain where we are working. Okay, and if you want to drop, we have drop option here. Drop NA will drop those data set, or we can use fill NA and we can go for a mean for this whole data and place those values in the missing places. Okay, so here we can see few examples here, or we can also have your own predictive model for that particular feature, so that you can apply that and use it. Okay, now if I go ahead and print, now I can see that okay, this is a good data. Now I should be able to use this information to predict something, or to feed to the machine learning algorithm. Okay, so but machine learning works with the numbers. It understands only the numerical data. So but here I can see some of the categorical data like male, female, S, C. Okay, these are some of the categorical information, and rest of the data is numerical. That's good. Okay, so now we can convert. There is something called label encoding, and there is something called one hot encoding. Okay, so at least in this case we can go with the label encoding for now. The 6 column have only two the possible values, so we can go with the label encoding, but for embarked it is good to go with the one hot encoding. So maybe we'll discuss in detail sometime later, but for now I'll go with the label encoding for each of this. Let me go with the Titanic 6 column equal to Titanic dot 6 dot apply, and I can apply, let's say, lambda LA, and I'll return one for all the males. Okay, so let's say if it is male it is 1, otherwise it is 0. Okay, I think this way. Okay, so that is how I can change. Let me just check it if it has taken effect. So male, female, 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 male, 1 0 0 0 1. So that's how the data got converted from the categorical data to numerical data. Okay, using label encoding. So here I am using apply function. You might use map function or whatever mechanism you want to do. You can go ahead and use. Now let me also try and handle embarked. Okay, so how this embarked look like. So let me just check how many values, unique information we see. Okay, so we see that there are 3 and there is one NaN, right? Strange, because we didn't noticed there is something called missing information for this also embarked. Look at this. Now I see that there are 889, means couple of records are having Na value. So NaN. So that means we can either drop those, or it is up to you if you want to randomly pick one of these 3 and put there, but for now I'll go and simply drop Na. Okay, so that those records will be dropped, and I use, don't forget to use in place, because this will then do your changes in memory, okay, in the data frame. So now look at this. So I got only these 3 different categories here, correct? So now we can use label encoding for this, and probably you can transform this information as well. So let me show you how this looks like. So I don't think there is any difference as of now, but look at this. This is the data, and our original data had so much of the information. Okay, so this is what is all about, exploring your data, understanding your data, analyzing, using some of the technical or statistical tools, methodologies to handle your data, convert your data, or if needed you can merge or split, or apply different techniques like one hot encoding, or some logic to replace or to fill up the missing information. So that is all about exploratory data analysis, where the majority of the time of a data scientist, or a person who is working on data science project goes. Okay, so right after collecting the data, there is a stage where we have to analyze that data, we have to explore that data, and then we can make that data ready for processing by some of the machine learning or statistical techniques to to have some predictions out of this data. Okay, so this is about the data science exploratory data analysis part. So we will discuss further the next topic in the next video. Okay, thank you guys.